the figure shows resistors connected to a 4-volt power supply. The question is that we are asked to calculate the effective resistance of the circuit. Remember, this circuit is called a series parallel circuit, which means that resistors are connected in both parallel as well as series. Okay, yeah, so that is a very important thing to note. Okay, so now let's calculate the effective resistance. So we're first going to start with resistors in parallel. So let's find the effective or total resistance for resistors in parallel. The formula that we're going to use is 1. Let me use a black one. Okay, so we're going to say 1. Okay. Okay, we're going to say 1. Okay, I don't like the size of let me increase the size. Okay, so we're going to say 1 over R is equal to 1 over R1 plus 1 over R2. Okay, after doing that, we're going to put 6 and 12 there. So we're going to say equals 1 over R1 is going to be 6 plus R2 is going to be 12. After doing that, we can find the lowest common multiple. Okay, so it's going to be 12 into 6 into 12 is going to be 2 times 1, 2, plus 12 into 12 is 1 times 1, that is 1. Okay, okay, sorry. And then we're going to add 1 plus 1 plus 2, which is going to give us 3 over 12 equals 1 over total resistance. Okay, so we have to go on, and then we're going to cross multiply 12 by 1 is going to give us 12 equals RT, okay, 3, and then we're going to divide 3 throughout, which is going to give us yeah, RT is equal to 4 ohms. Okay, so we have actually calculated the total resistance for resistors in parallel. Let's now calculate the total resistance for this and the one that we have now calculated, because this one has now been replaced by a 4 ohm resistor. Okay, so we can get rid of this. Okay, so we're going to start. So we're going to say, therefore, total resistance is equal to R1 plus R2. R1 is going to be 3 plus R2 is going to be 4, and then the total resistance is going to be 7 ohms. Okay, that's the total resistance. Okay, as simple as that. So I'll as well get rid of this. Okay, so we have the total resistance. We can now move to the other question. Okay, calculate the potential difference across 3 ohms resistor. So we have been asked to calculate the potential difference across the 3 ohms resistor. This here, 3 ohms resistor. Now, what we're going to do here is that we're going first of all going to find the current that is passing through the whole circuit. So we're going to use this formula. We're going to say voltage is equal to current multiplied by resistance from Ohm's law. Do we have the voltage? Yes, the voltage is here passing through the whole circuit, so which is going to be 4 equals current. Do we have the resistance? Yes, we just calculated the total resistance passing through the circuit, which is going to be 7. Okay, so from here you can divide 7, and here you divide 7. So okay, you divide 7. Okay, as the end of it all, you're going to say current is equal to, when I do the math quite properly, I'm having 0. 0.57 amps. Okay, so this was the current passing through the whole system. Okay, so let me get rid of this. So after calculating for current, we can therefore calculate the potential difference passing through the 3 ohm resistor. How are we going to do it? We're going to say voltage is equal to current multiplied by resistance. Okay, after doing that, we're going to say, okay, the potential difference is the voltage. So we're going to say V is equal to, current is how much? 0. So the current is 0. I'm having challenges, in writing the point. So I'll just write a simple point like this. 0.57. Okay, hope you're able to see 0.57 multiplied by the resistance, which is the 3, because they asked us to calculate the resistance for 3 ohms, the potential difference for 3 ohms resistor. So we're going to put a 3 there, and then we're going to do the multiplication, which is going to give us 1.7 volts. So this is what we were supposed to do. Okay, that is very easy. Thank you very much for watching.